So in this lesson I'm going to talk about three things: sound integration with the animation, instantiation or spawning and object destruction, and physical collisions between objects. While it might seem a very straightforward solution, if it is walking, it's playing the step sound, the reality is a bit more complicated, especially in the situation where we have more than one animator, one for the front view and another for the back. If you select one of the views and go to the animation window, you can notice this Add Event button at the top of the track controls. We change to the walk animation and select the frame where the foot is on the ground. Now we can add an event to trigger our step sound. But the configuration for this event is quite basic, and here is where the problem resides. Yes, we can trigger a method from here, but the class or the script that contains that method needs to be in the same gameObject to work. This means we cannot have a sound player in the parent gameObject and access it from the animators in the child object. The solution is to have a script in every child object that triggers the sound player. At the same time, we have yet another problem. If you remember from the last class, both animators are synchronized. Even when we don't see the back view, we are still playing that animation, which means that the triggers for the sound will happen anyway. This will result in two sounds every step, and we also need to address that problem. So, in order to keep these lessons accessible to beginners, let's go to not the most elegant or efficient solution, but the one easier to understand. Instantiation, or spawning as it may be more commonly known, it's the process of adding a gameObject to the scene while the game is running. Similar but the opposite of that is the destruction of a gameObject, which is the removal of an object from the running scene. A simple example is picking up coins when you pass through them or eating the enemy. So, picking the coins is destroying the object, and hitting the enemy is instantiating coins gameObjects. I will actually use this technique to play the sound for our character. We need a step sound every time a foot goes on the ground, and we can just instantiate a gameObject with the sound inside, and eventually destroying the object once the sound has completed. This means that every step will be an autonomous object responsible for itself, instead of having a manager playing sound files and dealing with many players. And you may ask, why do you need more than one player? Is there one for each foot? No, it is to allow a sound to play without interrupting the end of a previous sound. For example, if you are walking in a cave, the steps can have echo, but you don't want to cut the echo because of the next step. This is actually a bad example because Unity can add echo in real time, so no need to have echo in the sound itself. But it's just a way to describe a situation where the size of the sound is bigger than the time we need to wait to play the next sound. A prefab is a ready-made game object with all the tiles and variables assigned and scripts and components prepared to be dragged to the scene as a working element. We actually need a prefab of the sound player if we want to instantiate while playing. Every object that needs to be instantiated has to be a prefab. So let's build this sound player, and when it's ready we can create the prefab to use it every time we need. Right-click on the hierarchy, create an empty object and call it SoundStepGrass. Reset the transform and add a component called AudioSource. This component can hold and play just one sound at a time. Disable Play on Awake and set the volume to 0.5. As you can see, there is no sound file yet, but we will not add the sound here manually. We will create a script to do it. Why? Because we are not using only one sound file for the step. We have a library of sounds, and the script randomly chooses one to play every step. This will make the sound more realistic because there is no repetitions of the same sample, to be like in a real-world situation. Eventually, we can duplicate this sound step grass gameObject and change the name to sand, for example, and add sand step sounds to it. But that is for another lesson. Create a new script called PlayRandomSoundFX. To select a sound and play it, this script needs to have access to a list of sounds and an audio source component. The list of sounds will be a serialized field. In the inspector, you will be able to drop your files there. The reference to the audio source will be private. Eventually, we will add the correct audio source automatically in the start method. So, serialized field, audio clip, open square brackets, close square brackets, space sounds, semicolon. This is a variable called sounds of the type audio clip, so it's expecting sound files or audio clips, and it is configured to be an array. An array is like a list where you have multiple values inside and you access them by the number that represents the position in the list. Well, it's not a list. Actually, there is a thing called list, similar to the array, but not exactly the same. If you declare a variable with square brackets after the type, you are creating an array that can hold many elements of that type. Anyway, we are creating an array of sound clips. Later, we select one of them and send it to the audio source to play it. If you go to Unity and add the script to the gameObject, you can see the array with 0 elements. You can add or remove one by one with this plus and minus sign, but it is more efficient to lock the inspector, select all the sounds you need here, and drag them to the variable name. Don't forget to unlock the inspector at the end. Now let's add the logic to make this work. We need to send a file to an audio source. Audio source sound player semicolon. This variable is private by default and we need to make the script find the audio source by itself. So to make the sound player be the audio source, sound player equals get component audio source. After that, we randomly choose one of the files inside of the array and set it as the clip in the audio source. Soundplayer.clip equals sounds, open square brackets, and now we get the number, but it's a random number, so random.range 0, sounds length to get the size of the array. This will randomly choose a sound from 0 to whatever number it has inside. And at last, we play the sound, soundplayer.play. Eventually, this object needs to be removed and we do that by checking every frame if the sound player is still playing. And if it's not, we destroy the object. If soundplayer.isPlaying is equal to false, destroy this .gameObject. Return to Unity and drag the SoundStep gameObject to the Prefab folder in the project panel. This will transform that object, as it is, into a prefab. Now, if you need an object equal to this one, you just drag it to the scene. Once the prefab is made, you can delete it from the hierarchy. Now run the game and drag a prefab to the hierarchy panel. Every time you do this, you will have a step playing, and as you can see, they disappear automatically once they are done. A quick side note, this is not the most efficient way of reusing objects. There is a technique called object pooling, where you already have the objects there and you just use them, and when you don't need them you disable them, more or less like this, but that technique implies a different configuration and is not very easy for a beginner, so we stick with this instantiation and destruction, but eventually if you want to learn about pooling, go check some links in the description. Now to play this sound, we do it by instantiating the game object every time we need it. To do it, we will need to trigger it from the animation actions. But for that to be possible, we need a script with a method to hold the command to execute that. Create a new script and call it RoboSoundTrigger. Edit it and delete all the methods. Two variables will be needed: a boolean to enable and disable the instantiation, public bool can play, and the gameObject to instantiate, serialize field, gameObject, step prefab. The boolean needs to be public because it is the Robo script that is going to change this to true or false. Create a new method and call it triggerStep. Public void triggerStep, open and close curly brackets. This method needs to be public in order to run it from the animation. Now inside we code the instantiation command. Instantiate step prefab, transform position, quaternion identity. Instantiate is expecting three arguments: the object to instantiate, the position where, and the rotation with which the object will be instantiated. This will instantiate a step player every time a trigger step is called, but as I mentioned before, both animations, front and back, are running at the same time, and two triggers will happen. We use the boolean to prevent the disabled view from triggering a sound. Before the instantiate command, add if canPlay is equal true. This will only instantiate if the boolean is true, and we can control that from the Robo script. Every time we disable the sprite renderer to hide a view, front or back, we also disable this boolean. To accommodate that, the Robo script needs to be altered. Let's edit Robo to add these features. First, we will need another reference to access the RoboSoundTrigger script from the front and the back childs. To prevent any more dragging in the inspector every time we need a reference, like we did with the animator and the sprite renderer, we are also changing the way this gets inside the script. So let's just add a manual reference to the main child gameObject, and then in start, as we did with the audio source, we get all the components for each variable automatically. So serialize field gameObject Robo back, serialize field gameObject Robo front. These are the gameObjects, and now we can use them to get the renderer, the animator, and the sound trigger. So these no longer need to be present in the inspector, and we need to add a new one to the RoboSoundTrigger. Animator back body anim, sprite renderer back renderer, RoboSoundTrigger sound back. Now let's do the same thing for the front view, and the start method will do the rest. Back body anim equals RoboBack dot get component animator, back renderer equal RoboBack get component sprite renderer, and sound back equal RoboBack dot get component RoboSoundTrigger. Now let's repeat the process for the front view. Front body anim equals RoboFront dot get component animator, front renderer equal RoboFront get component sprite renderer, and sound front equal RoboFront dot get component RoboSoundTrigger. At this point, if you play, everything will be the same. We just improved the way we reference the components. But before we play, we need to add the command to change the boolean and allow the instantiation to happen on the correct script. So down here, where you set which renderer is enabled, you will add another line to enable the triggering. So if back renderer is false, sound back is also false, and if front renderer is true, the sound front is also true. backRenderer.enable equals false, soundBack.canPlay equals false. FrontRenderer.enable equals true, SoundFront.canPlay equals true. This is the negative direction, so let's do the same logic for the positive one. BackRenderer.enable equals true, so SoundBack.canPlay equals true, and FrontRenderer.enable equals false, so SoundFront.canPlay equals false. Now we should have a front and back object independent on the render side and the sound playing side. Other sounds can be applied to other parts of the main character's game object, but all depends on the purpose of the sound and how it is triggered. Some may need to be inside each animation, others may be on the main object. To make the animator trigger the methods, select one of the views of the Robo and in the animation panel find the walk animation. Put the playhead where the step starts and right-click on the Events track and select Add Animation Event. In the inspector, set the function to Trigger Step. Do the same for the other step and also in the walk animation of the other view. Now that we understand the purpose of a prefab, let's create a bunch of them. In the nature element sprite, you can find many trees and rocks. Select the sprite in the projects panel and set it to 300 pixels per unit. These drawings were made at the same scale as the robot. This means they don't need to be scaled to have the correct size, they just need to be in the same pixels per unit configuration. Also, this sprite has many elements and we need to separate them. Unity has this option called sprite mode that you can set to multiple. Now at the bottom, set the max size to 4096 and apply. You may notice the image disappeared from the project panel. This is because there is no sprite configured in that multiple image. To set the individual sprites, you go to the sprite editor and create a rectangle around every single element. The rocks can be single elements, but every tree element needs to be grouped into a single sprite, so we can add a skeleton and animate it. You can adjust the rectangles to be tied to the sprite and give names to them. For this class we actually just need one tree and one rock, but eventually you need to do all of the others. At the end, click on Apply. Before returning to Unity, don't forget to add the bones to the tree. Go to the skinning editor set the bones from the bottom to the top connect the leaves to the correct branches and give the appropriate depth. Apply and return to Unity as soon as it's done. By the way, the rock doesn't need any bone. Now drag the tree to the hierarchy, reset the transform and add the sprite skin component to create the bones. Set the main bone to 0 in X and Y and assemble the rest of the tree from there. In the Animations folder, add a subfolder called Trees and create a new animation inside. Call it Tree 1, Idle 1. Eventually, on other trees, you increase this number. add it to the main tree object and edit the animation to give the tree a slight movement. Once you have the left and right position, copy the first frame and offset a little the keyframes in the middle. Stretch the animation to around 10 or 20 seconds and it should be enough to look like it has some wind around. If you return to Unity and play, you should be able to walk around the tree, but there is a problem. Somehow, the depth of the character is not correct. At this point, the robot should be behind the tree and not flying in front of it. To solve this, we need to tell Unity in which order it should draw the elements. We are going to use the position in the y-axis to set if the element is behind or in front of each other. Go to the Edit menu and select the Project Settings option. A panel will open. You can also dock it alongside the inspector, you may need it later. Now on the graphics settings, select the Transparency Sort mode to Custom and set it to X0, Y1 and Z0. This will solve half of the problem. Now Unity knows that what is below should be in front, but the reference is the center of the sprite. We need to custom pick a point for each character. To do it, you go to the sprite editor of the robot back, for example, and drag this pivot point to the center of the shadow. Click on Apply and do the same thing for each other asset. Always put the pivot point at the center of the base of the object like if it was a 3D object. Now on each sprite renderer you need to set up the sorting point to pivot in order to make Unity use our custom point. Now it should work properly, but we can walk through the tree. I guess we need to collide with the tree. For collisions to happen, two components are needed, the rigid body and the collider. The rigid body is the component responsible for adding some physical properties and simulating gravity. In this case, we don't need the gravity calculations because falling would look like the character was walking down, but we need the presence of the body to assume a physical existence in Unity. The collider is the component responsible for delimiting the area we are going to use as a physical area and to take in consideration during collision detection. A collider can work as a trigger and not have a physical reaction to another physical object, but that is for another lesson. Notice that Unity has two different physics engines, the 3D and the 2D. Unity started to be a 3D platform by default, and that's why the 3D is not present in the name of the components. What you really need to know is that they behave the same way and you use them the same way, but they are totally different and not compatible. Because our game is 2D, we need to use the 2D version of the physics. So, select the Robo main object and add two components, a rigid body 2D and a polygon collider 2D. In the rigid body 2D component, set the gravity scale to 0 and freeze rotation inside the constraints. You can close the component. In the polygon collider, open Points, Path, and Element 0. If you have more than one element, set it to 1. The size needs to be 4. Now you can see that the green pentagon is no longer a pentagon, and it has only 4 vertices. To edit the shape, you click on the top button called Edit Collider and drag the corners to the area of the shadow, respecting the perspective of the drawing. In this game, we are going to add colliders to the base of every interactable object, like if they were standing on the ground, and the behavior of the collision will appear correct for the force point of view of this perspective. To test this, we actually need to do the same thing to another object, so select the tree and do the same. A rigid body 2D with zero gravity and constrained in all three axes, and a polygon collider 2D set to the base of the tree. You can also do it to the rocks. They are very static and don't have animations, so they don't need bones or animations. They don't even need a dynamic rigid body, so on the rocks you can set the rigid body to static. It's less expensive for the CPU. Now that our character and tree are mainly ready, we can set them as a prefab. Drag the tree, the rock and the robo to the prefab folder one by one. Now, if you need more trees and rocks, you just need to drag them from the prefab folder to the scene and design your level. In the next lesson, I'm going to talk about the triggers and how to make some objects interactable. While the next lesson is not available, you need to create the other rocks and trees as prefabs, and also have at least 2 different idle animations per tree. Check also this video description and follow the links there to other tutorials with more information on these subjects. So I hope you learned something new with this lesson, and I'm expecting to have you in the next one. Bye!